So in this video, we are going to talk through how to graph horizontal and vertical lines. So far, most of the graphs that you've seen have contained two variables, both an x and a y. And the discussion we're going to have today is, can we actually graph equations with only one variable? So things that look like the following. So here we have y equals 5 or x equals 5. Can we graph those? And the answer is yes, and that's what we're going to focus on today. Our first step when we do this, in order to graph these, is you need to get the single variable alone. So when we had both x and y, we always solved for y by itself. If we only have one variable, you're going to start by getting that single variable alone. So here, if we look at 4y equals negative 20, hopefully you're realizing to get the variable by itself, we divide both sides by 4, and we find y equals negative 5. Or over here in the second example, we would start off by adding 2 to undo that negative 2. So we have 3x is equal to 8. And then we divide both sides by 3 to get x equals 8/3. So we're always going to start, if we have just one variable, by getting that single variable by itself. Then, once we have that single variable by itself, it's actually a fairly simple process. We simply need to think through what that equation is telling us about our situation. And if we look here, what I notice is we have y is equal to 4. So what this is saying is that the requirement for every point on this graph, so for every point, y has to equal 4. That is what this equation is telling us. So what we can do is we can go to where y is, and we can say no matter what the point is, y is going to always equal 4. Now, the cool part about this is that there aren't any restrictions on x. They don't tell us anything about x here. It's only y. Y has to be 4. So we can pick anything for x here, because there's no stipulations for it. So we could pick negative 5, 0, 4, and negative 3. It doesn't matter. We can pick whatever values for x we would like. Then from here, we're going to label. So these are all going to be worth 1. So we'll do 1, 2, 3, so we can see that. And then here, we're going to have each of these worth 1 as well. So what we're going to do is we're just going to go, we know that y has to be 4, and we picked whatever values we wanted for x. So we're going to plot each point. X is negative 1, 2, 3, 4, 5, 4. So I can see that point there. I have negative 5, comma 4. Then I have the point 0, comma 4. Then I have the point 4, comma 4. And then I have the point negative 3, comma 4. And hopefully what you're starting to see is when you have all your y values equal to 4 and your x values not having any restrictions, is as you plot all of those points, they begin to form a line horizontally. So we have a horizontal line here where all of the points have a y value equal to 4. Now, for these lines, our domain and range are a little bit different. Here we can see that our graph is going forever to the left and forever to the right. So what this is telling us is that our domain is still all real numbers because we're going forever right and forever left. We're using all of those horizontal number line values. But where this is different is on the range. So the range itself, if we look carefully, what we're going to notice is that the range only has one particular y value. The range are all of our outputs. All of our outputs are equal to 4. Here, the only y value that we're using to make any of these points is y equals 4. So all of our outputs are equal to 4, and as a result, our range is only equal to 4 as well. So now here we have a second example, and if we look here, we see x equals negative 5. So what this is telling us is that for every single point that we graph, so for every point, x has to equal negative 5. So for every point that we pick, x values need to be negative 5. But y values can be anything because there's no stipulations on y in this particular equation. So here for y, say we picked 3, negative 1, negative 4, and 6. So here I'm going to number my values. So that's 1, 2, 3 to stipulate these are each worth 1. And these are each worth 1 as well. And all I'm going to do here is I'm going to go through and I'm going to plot my points. I notice x is always -5, and then I picked some y values. So we're going to start by going to x is -1, 2, 3, 4, 5, y is 3. So this is the point, x is -5, y is 3. Then x is -5, y is -1. X is -5, y is -4. X is -5, y is 1, 2, 3. Oop, I plotted this one a little bit too low there. Sorry about that. And then this last one here is x is -5, y is 6. And what you should be noticing here is that when all of these x values are -5, we form a vertical line. And then from here, all we need to do is determine our domain and our range. My domain, what I notice is that I only have one input value. My single input value is x equals -5. So that's all my domain is going to be. For my range, what I notice is that my graph is going forever up and forever down, which tells me that my range is going to be all real numbers. So now that we've done a couple easy examples, let's start to make it a little more difficult. Here, what we're going to do first is we're going to need to get our variable by itself. So when I look at this equation, what I notice is there's only one variable. And if there's only one variable, I need to get that single variable by itself. So I start by subtracting 5 on each side. So I have 6x is equal to 12. I divide both sides by 6, and I find x is equal to 2. So that's my equation that I need to graph. Now from here, what this is telling me is that for all of my points, my x values need to be 2. And then from here, what it's telling me about y is that y can be anything. There are no stipulations for y. So I'm going to pick -5, 3, 0, and we'll pick -2. There doesn't need to be a specific value that we pick. So now we're going to go and plot these on our coordinate plane. So I have x is 2, y is -1, 2, 3, 4, 5. So there's x is 2, y is -5. X is 2, y is 3. X is 2, y is 0. X is 2, y is -2. And what I notice here is that I have a vertical line forming when all of those x values are 2. So here I have a vertical line forming at x equals 2. And then finally, I need to determine my domain and my range. My domain, I notice that I have all of the same value for my inputs. So my domain is x equals 2. My range goes forever up and forever down. So it's all real numbers. All right, and final example here. So we're going to start by getting the y value by itself. And what I notice is that y is being multiplied by 1/2. So what I'm going to do to get y by itself is I'm going to divide both sides by 1/2. So I have y is equal to 3 divided by 1/2. Well, I know I can turn that into multiplication by multiplying it by the reciprocal. So this is really saying y is equal to 6/1, so 6. So what this is telling me is that for every single y value, the y of that point needs to be 6. So regardless of the point that I pick, the y value needs to be 6. The x values can be anything. So let's maybe pick 4, 2, 0, and -2. Because the x's can be anything, the y's just need to be 6. So here I'm going to graph. I have x is 1, 2, 3, 4. Y is 1, 2, 3, 4, 5, 6. So this is the point 4, 6. Then I have x is 2, y is 6. So this is the point x is 2, y is 6. X is 0. I missed that by a little bit. X is 0, y is 6. X is -2, y is 6. So what I'm noticing here is that I have a horizontal line forming, And that's what happens when I have y is equal to 6. All of my y values equal 6. X's can be anything. So then from here I notice for my domain, I'm going forever left and right, so I have all real numbers. And my range, I notice that my only outputs are y equals 6, so my range is just one single value of y equals 6.